Everyone and welcome to IB Methodology, your space for mastering IBDP mathematics. In today's video, I am going to solve AAHL May 2025 paper 3. So let's start with a question. Now in this question, we have two unbiased dice with faces labeled as 1, 2, 3 and 4, and they are thrown and the scores are being recorded. So this is the table, which is the probability distribution table given to me. Now in the A part, we have to find EM. EM is nothing but the expected value. So we will use the formula using your formula booklet as this, which is X summation of the probabilities of individual events. It means we have to multiply 1 to this to this, 3 to 5 by 16 and 4 to 7 by 16, and since summation is given to me, so I have to add all of them. So I will be writing the multiplication along with the sum, and 4 into 7 by 16. So this is my expected value. So when you will solve this, since this is a paper 3, GDC is allowed. So when you will solve this, you will get this, or we can also write as 3.125. So this is your answer for A part. Now, an alternative way to represent the probability distribution of M is by using the polynomial function as this. Because there are 4 values of M, that's why they have taken the values from 1 to 4. And the distribution of M can be written as this. So we have to find G1. So for B first part, G1 means when your t value is 1. So we have to substitute t value in GT function. So I will be replacing t by 1 square plus 5 by 16, 1 cube plus 7 by 16, 1 to the power 4. So when you will solve this, you will get it as 16 by 16, which is nothing but 1. So this is how we'll solve B first part. Now for the C first part, it says G dash T. G dash T means differentiation of GT. So we will be differentiating. So 1 by 16 is a constant, T derivative is 1. 3 by 16 is a constant, T square derivative is 2T. 5 by 16 is constant, derivative of T cube is 3T square, plus 7 by 16, derivative of T to the power 4 is 4T cube. Now when we will solve, we will get 1 by 16 plus 3 by 8 into T plus 15 by 16 T square plus 7 by 4 T cube. So this is how we will get G dash T. We have to write the simplified answer. Now in this was the first part. Now in the second part, they are saying to show that G dash 1 is equals to EM. Now my EM value was 25 by 8. So I have to get my G dash 1 value as 25 by 8. Again, I will be substituting T as 1 in my above result. So I will be getting 1 upon 16 plus 3 upon 8 into 1. 15 by 16 into 1 square plus 7 by 4 into 1 cube. And when you will solve using your GDC, you will be getting 25 by 8 or 3.125, which is nothing but your value of EM. Now for the next part of the question, we have a bag that contains 2 red and 3 yellow balls. 2 balls are selected without replacement. This is very important. And the random variable X denotes the total number of red balls selected. So we have to concentrate on red ball. And the probability distribution is given to me like this. Now we have to show that this should be my answer, making it clear how the coefficient of Gx have been determined. So first we will attempt to find at least one required probability. So for that, I can put my X is equals to 0. X is equals to 0 means we have no red ball. So for no red ball, we have 3 yellow ball So we have 3 ball. Out of the total was 2 red and 3, total becomes 5. Now this is the probability of 1 ball, and we have to find 2 balls, probability of 2 balls. Since 1 is already taken out, so next probability will be 2 by 4. So this will give you answer as 3 by 10. Now what if in drawing 2 balls we have to find probability of when there is 1 red ball. So since there are total 2 red balls, so in the first one we can have 1 red and 1 yellow, or we can have 1 yellow and 1 red. So for 1 red the probability will be 2 by 5 multiplied by, for 1 yellow there are total 3 balls and 1 has already been taken out, so the total becomes 3 by 4. For the next one, if I am drawing out any yellow ball, so out of 3, I am taking 1 yellow ball. Now again, 1 ball is already been taken out and there are total 2 red balls and 1 is being taken out, so I will write it like this. And this will lead me to an answer 3 by 5. The next one is probability of when x is equals to 2. Again, if I am saying when x is equals to 2, it means it should be 2 by 5. From any of the 2 red balls, I am taking out 1 and now I am left with 1. So I can take 1 upon 4. This is when you have 1 red. This is when you have second also as red. So this will give me an answer as 1 by 10. Now we will be writing the GT, which is summation x is equals to 0 to 2, x is equals to x to the into 2t to the power x. So I have to put x as 0. So it means I have to calculate for x is equals to 0, x is equals to 1 and x is equals to 2. And these are my results which I got above. So when I will be substituting these value, I will be getting my answer as 3 by 10. It should be multiplied by t to the power 0, that becomes 1. So that's not, I am not writing, into t to the power 1 plus the last answer I got as 1 by 10 t square. So this is how we will show the value. The next part of the question, it says the probability distribution of y that can be represented by the polynomial function gy is this. Given that the coefficient of t square is 1 by 3, we have to find the value of p. Now, to solve the first part, we have to be very careful because we have 2 coins and we can write the probability of unbiased coin, as pt, which is half, and another one is the biased coin, which is pt as p, which I have to find out. So probability of 2 tails we have to find. So I can write it as 2 tails, which is nothing but p of y is equals to 2. It should be unbiased coin, which is half, into biased coin, which is p. So I get my answer as p by 2 here. Now, given the coefficient of t square in GT is 1 by 3 and I am getting my value as p by 2. So I can equate. On equating p by 2 with 1 by 3, I will get my p value as 2 by 3. This is how we'll solve E for first part. Now it says in the second part we have to find the expression. Expression means we have to solve for y is equals to 0, y is equals to 1, y is equals to 2. Y is equals to 2 we have already solved. Y is equals to 0 means we have 2 heads. So, and for 1, y is equals to 1, I will be solving. So let's start with probability of y is equals to 0, means probability of both head. So for the first one, probability of head will be 1 by 2, and we have calculated probability of tail as P for the biased coin. So for head it should be 1 minus P. So I will be substituting my value of P here. I will be getting 1 by 6 as the answer. Now for probability of y is equals to 1, I already have calculated as 1 minus P, but here P will be 1 by 6. Why? Or you can also say that this is for y is equals to 1, so I can subtract it with 1 by 6 and we have to subtract 1 by 3 also from this. So for 1 by 3, because we have the coefficient already given to us as 1 by 3, so this is coming as 1 by 2, and for probability of y is equals to 2, we already are given as 1 by 3 as the answer. So combining 0, 1 and 2 values, I can write this function as for y is equals to 0, for y is equals to 1 and for y is equals to 2. I get my function like this. Now in the next part of the question it says the random variable z denotes the sum of total number of red balls selected in x and the total number of tails obtained in y, and the probability distribution is given to me as gz function. Gz is multiplication of the above two functions. So for the random variable it can be shown as g dash 1 is equals to ez. We have to find the result of ez. So first I will write what we are given with. So this is gxt into gyt, and my ez is nothing but derivative of gz at 1. So we can use expectations of sum, which is given to me as ez is equals to ex plus ey, which is written over here the sum total. Now to find ey, which is total number of tails obtaining from tossing both the coins, for getting 2 heads it should be this, for getting 1 it should be 1 into 1 by 2, and for 2 it should be 2 into 1 by 3. So this I am again using that formula x into p of x is equals to x. So on solving this I will get 7 by 6 as my answer. So I can substitute this in this equation 1. So I will get ez as ex plus 7 by 6. Now we can insert the previously found value of ex if it is given in the question. So ex is nothing but g dash x at 1, and I had my g dash x function as 3 by 10 plus 3 by 5 into t plus 1 by 10 t square. So I can substitute t as 1. So I will be getting I will get g dash x1 as 4 by 5. So I can substitute here. So my ez will be 4 by 5 plus 7 by 6. And then using GDC, I will get my answer as 1.97. Now let's move to question number 2. Now in this question, the function f can be differentiated twice, and for curvature k, the function is defined as this, and we are given with the linear function gx, and we have to show that k is 0 for this family of linear function. So for this, I will take my gx function as mx plus c. So if I will differentiate this once, I will get m, and when I will differentiate it twice, I will get this as 0. I will be using my kx function, which is modulus double derivative upon 1 plus single derivative to the power 2 3 by 2. So I will be substituting single derivative as m and double derivative as 0. So it is 0 upon 1 plus m square to the power 3 by 2, which is nothing but 0. So this is how I will show this answer. Now in this part we are given with the family of quadratic function as this, and for this family it is given that kx is and k dash x, these are the two functions given to me. Now by solving k dash x is equals to 0, we have to find the value of x where k max occurs. So since we are given with k dash x function, so if I put k dash x function as 0, so this is my denominator which will automatically be 0. So I am left with 2ax plus b is equals to 0. Since a and 12 are constant, so they'll also be 0. So I am getting 2ax plus b equals to 0. So x is nothing but minus b by 2a. So this is my value of x where k max occurs. Now for the second part we have to find the expression of k max. So to find the expression of k max, I have to substitute the value of x is equals to minus b by 2a in the kx function which is given here. So if I replace x with minus b by 2a, numerator is this. Now 1 plus 2a multiplied by minus b by 2a plus b whole square to the power 3 by 2. So this will give me as 2 modulus a. This a will get cancelled out, 2 will get cancelled out. So I will get 1 plus minus b plus b whole square, which is 0 to the power 3 by 2. It means I am getting 2 modulus a as my answer for this k max value. Now for the third part we have to find the value of this. So I will write it as x tends to infinity. My kx function is 2 modulus a 1 plus 2a. Now instead of x, since x approaches to infinity, whole square to the power 3 by 2. Since x approaches to infinity, so it becomes 2 modulus a by infinity, which is nothing but 0. So this is my value for when k tends to infinity. And we have to also explain briefly the significance of the result. So we can say that for large value of x, because x tends to infinity, so I can write that for large values of x, my quadratic function which is x, it is almost close to straight line. So this is how I can explain this. Now in this we are given with two quadratic function px and qx. Now we have to state which one of the following is true for k max. So for k max, in the earlier part we got k max as 2 modulus a for my kx function. So for px, if I am talking about, so for px, a is coefficient of x square which is minus 2. So k max of px will be 2 modulus minus 2 which is 4, and for qx my a value is 2 because it is again coefficient of x square. So k max of qx will be 2 modulus 2 which is 4. So it means my k max for p is equals to k max for q. So my answer is option C. Now we have to consider the function vx as ln x, and for v it is given as again 2kx and the derivative. Again we have to determine the exact value of x where k max occurs. So k max occurs means we have to set k dash x is equals to 0. So when I will put k dash x is equals to 0, my denominator will go to right hand side, that will become 0. So x square value is coming as 1 by 2, means x is 1 by root 2. So 1 by root 2 is the answer. And why I am not taking x as minus 1 by root 2? Because my vx value is given to me ln x, and inside ln the function should be positive. So we will not be taking minus 1 by root 2 as our x value. And for the second part we have to show k max as this. So again I have to substitute my x value as 1 by root 2 in the kx function. So my k max value will be k 1 by root 2. So I will be substituting x as 1 by root 2 everywhere. So it is 1 upon 1 by root 2 whole square to the power 3 by 2. So when we will solve this, I will get k 1 by root 2 as 1 by root 2, 1 plus 1 by 2, but it is 1 by 2 whole square. So I will write it like this, 3 by 2, which is 1 by root 2, 1 plus 1 by 4 to the power 3 by 2, which I can write as 5 by 4 to the power 3 by 2. Or because I have to get my answer as 2 root 3 upon 9. So instead of writing it as this, I can write it as 3 by 2 to the power 3 by 2 also. So if I write denominator as 3 by 2 to the power 3 by 2, so this I can write as 1 by root 2 and denominator will be 3 root 3 by 2 root 2, which on simplification will give me 1 by root 2 into 2 root 2 by 3 root 3, which is nothing but 2 by root 3. Now I have to get 9 in the denominator, so I will be rationalizing it. So I will get my k max as 2 root 3 by 9. So this is how I will solve this. Now in this part we have the function as e to the power x, and again kx and k dash x is given to me. We have to now show that k max value is this. So to show that, first I need to find the value of x. So I will be again putting k dash x is equals to 0, which will give me 1 minus 2 e to the power 2x as 0. So e to the power 2x is nothing but 1 by 2. So e to the power x as 1 by root 2. Now we can substitute e to the power 2x and e to the power x value in kx to get the k max, or you can use your GDC also, and instead of this you can also write x as 1 by 2 ln 1 by 2, which you can substitute. So I will be substituting. I can also write this as 1 by 2 to the power 1 by 2. So my x value becomes ln 1 by root 2. Now I will be substituting this value in my kx function. So for k max, if I substitute x as ln 1 by root 2, so e to the power ln 1 by root 2 becomes 1 by root 2 plus 1 upon 1 plus 1 upon, this is e square, so 1 by root 2 whole square to the power 3 by 2, which will give me 1 plus, again 3 by 2, this I have already solved in the above part, 3 by 2. So I will get my k max value as 1 by root 2 upon same 3 root 3 upon 2 root 2, which is 1 by root 2 into 2 root 2 by 3 root 3, which is 2 by 3 root 3. But again I have to get 9 in the denominator, so I will be rationalizing this. So on rationalizing I will get my answer as 2 root 3 by 9. Now we are given with the family of curve as y is equals to under root r square minus x square, and we have to show that double derivative is this. So to find double derivative, I can write the given function as this. I can find out the derivative, or let's start by keeping this as under root only. It will be the same. So if I take out the derivative, I will apply chain rule, which will give me r square minus x square to the power 1 by 2 minus 1 multiplied by the derivative of r square minus x square. So if I further simplify this, this will be minus half, and r square is a constant, so derivative is 0, minus x square derivative is 2x. So this will get cancelled out, so I will get my answer as x upon under root r square minus x square, which is nothing but y given to me in the function. You can see it here. So I got my dy by dx as minus x upon y. Now I have to find out the double derivative. So I will again differentiating dy by dx. I can apply quotient rule. So I can say that y as it is, x derivative is 1 plus x derivative, y derivative will be dy by dx whole divided by y square. I have applied quotient rule over here. So I can write it as minus y plus x. My dy by dx value is minus x upon y, which I just got here, whole divided by y square. On further simplifying this, I will get minus x square by y upon y square. Now I can take LCM in the numerator. So I will get this whole upon y square into y becomes y cube. So I can take minus common. So y square plus x square whole divided by y cube. Now if I write my y square as r square minus x square, which is given to me in the question, and I take this x square to the left hand side, so I will get r square. So I can substitute this as r square over here. So my d2y by dx square is coming as minus r square by y cube. So this is how I'll solve first part. Now for the second part, it says show that the curvature k is a constant for this family of functions. Now for this we can substitute k value in the kx function, the value of first dy by dx and then the value of d2y by dx square. So I will be writing kx function here. My kx function was double derivative of the function plus 1 plus single derivative of the function whole square to the power 3 by 2. So here if I substitute double derivative, which was minus r square by y cube divided by the single derivative was minus x upon y whole square to the power 3 by 2. So if I further simplify this, I will get 1 plus x square by y square to the power 3 by 2. I can write it as r square by y cube upon I can take y square as LCM to the power 3 by 2, and earlier also I have written x square plus y square as r square. So I can write this as r square. So my kx function will be minus r square by y cube divided by again r square by y square to the power 3 by 2. So 2 cancel out, r square by y cube whole divided by r cube by y cube, which will give me answer as minus 1 upon r, which is nothing but a constant. Alright, that brings us to the end of this past year solution. If this solution helped you understand the concept and exam approach, do give the video a like. If you have any doubts or would like to see more IB past year questions, feel free to leave a comment below. Don't forget to subscribe to IB Methodology for more clear and exam focused IB math content. Thank you for watching, and I'll see you in the next video.